You are up. So next up is Steve Zoak. Steve is the code advocacy engineer at ACI. His presentation is called Enhanced Resilience, Notable Programs and Strategies. And Steve, I've watched Steve present on resilience many times, and very, very good information every time. So I look forward to this. Steve, take it away.
Thank you, Claude. I am excited about being here. I'm hoping everybody can see my slides, and I'll start going through this presentation. Okay, I have a lot of information. I tend to prefer to use pictures and graphics, but unfortunately, since I'm talking about programs and activities, you're mostly going to see text and tables. But start with the fact that this whole resiliency thing becomes really complicated really fast, because you can have resilient buildings, you can have resilient infrastructure, but unless you have a mechanism for bringing it all together, you don't end up with community resilience, regional resilience, national resilience, and even international resilience. And all of those things are extremely important, but it all starts with individual projects being built to withstand inevitable disasters. And the reason I'm talking about this combination of things is there's this huge interrelationship between everything that we have to deal with when we're talking about resiliency. My fire station may survive an event. It may be extremely resilient, but if the fire station is over here and the problem is over here, it didn't make any difference that the fire station was resilient. So we need to make sure that whatever's happening with resiliency starts looking at the big picture and tying everything together. One of the very first groups to ever try to address resiliency and really has established many benchmarks for the models that are out there today is the San Francisco Planning and Urban Research Organization. What they did in, this probably goes back to the 1990s, they started with recognizing that many of their hospitals were very old and not built to the current seismic resistance levels necessary for what we learned we could expect in the San Francisco Bay Area. So they started a program to upgrade hospitals. And as they were doing this, they said, well, wait a minute, what about everything else? So they actually went and inventoried not just hospitals, but they inventoried by sampling some of the construction that was out there to determine how long it would take for those structures to become functional again. And this was a great first attempt. I don't think anybody preceded them in trying to come up with a baseline. And then you say, well, why are dwellings and services really important? Well, as soon as you start looking at things from the community level, you need the dwellings, because if you're going to have hospitals, the doctors and nurses need to live somewhere. They need to get fuel somewhere. They need to get to an ATM somewhere. Your fire and police officers, the same thing. They need these services in order for the community to really respond. Case in point is Third Ward after Hurricane Katrina. I remember being in dialogues with former director Craig Fugate of FEMA with Walgreens. Okay, they're trying to figure out how to get people to move back to the neighborhood, the Third Ward, and Walgreens is sitting there saying, you know, we lost the store there, and we have so many thousands of stores that rebuilding that store isn't important to us. Well, that devastated the entire ability to get that third ward repopulated because there were no services for people available to people who would have been interested in moving back. So all of this stuff gets really complicated. So then what San Francisco Planning and Urban Research did was they said, well, where do these structures really need to be? And they said, well, our hospitals, that they need to be operational right after the event, within 24 hours of the event at the worst case. And our fire and our police and our emergency shelters, the shelters you need to be able to have the shelters for the people within 24 hours. Schools, it could take a little bit longer, dwellings and services a little bit longer because there's temporary measures to provide housing and services that could be available after a disaster. Then as this started to grow and get more national attention, including the National Institute of Standards and Technology efforts and their guidelines for community resilience, you know, it started looking at, again, making it even a little bit more complicated of, well, what percentage of these structures need to be functioning at what point after a disaster? You don't need all the residences to be occupied within 30 days. Maybe it's only 20% within 30 days, and you know, maybe 50 more percent in 60 days, and you get to 100% in 4 months. So all of this stuff needs to be integrated into some sort of community plan. And I mentioned that it doesn't just stop at the community. These resiliency factors become far reaching. A good example of a national impact, Hurricane Katrina, we lost chemical plants and refineries. They were shut down, and that raised gasoline prices and even limited because of the chemicals that were no longer available. It even restricted the amount of unleaded fuel that could be produced elsewhere by other refineries. So it had clearly a national impact. We all saw the gasoline prices go up. And then another one had even a more global impact, the tsunami in Japan. What happened there is pretty much the only manufacturing facility that produced a key element for automobiles was taken out, and it stopped production of automobiles throughout the entire planet, all because of one disaster in one area. So this stuff is extremely important, and it requires paying a lot of attention to many implications. One of the earlier programs that tried to address resiliency was the Rockefeller Foundation 100 Cities. This program doesn't exist anymore. It's no longer funded by the Rockefeller Foundation, but I included it here because it started looking at how to determine what resiliency is and what it means for communities. Now, I picked San Francisco and San Diego because globally they're relatively close to one another. But when we looked at what San Francisco thought was important, it differed from what San Diego thought was important for becoming more resilient. San Diego doesn't have earthquake faults running right through it, so their emphasis on seismic wasn't nearly as great as San Francisco. So it clearly means different things to different groups. Their stressors are completely different. So then we start looking at and let me back up here one point. This resilient cities is actually gradually morphing into resilient cities catalyst. The resiliency cities program mostly helped communities and cities identify what their stressors are and who the right people are to bring together in collaboration to develop resiliency plans. And Resilient City Catalyst started in February of this year to try to bring the cities that were participating in the Rockefeller resilient 100 Resilient Cities program to move forward. So also on a more global scale, there's the Sendai framework that Julie also mentioned. And it again is looking at disasters from slightly different than most engineers will look at it, because it's looking at not just the physical structures and those capabilities, but it's looking at livelihoods, health, social, cultural, and environmental assets across the board. And fortunately also to that more expansive level of not just individuals and businesses and communities, but also to countries and global impact. But their targets tend to be a little bit different than, at that level, the targets tend to be a little bit different than the targets you would have for an individual project. I mean, they're clearly looking at the mortality of the disasters. They can be extremely huge when it's an island nation in particular. To reduce the number of affected people, and again, that could be global impacts as well as local impacts. The economic losses, clearly what the engineering community and construction community can influence the most is to help them provide infrastructure that will resist damage and disruption. So the Sendai framework is trying to increase the number of countries in their disaster risk reduction program, and trying to foster support and get organizations to participate in programs in those target countries, with the addition of early warning systems, which tends to also be outside of the design and construction community. The countries that are currently identified as priority are shown here in blue, and some that are earmarked for the Sendai Foundation and the DRR program of the United Nations are shown in yellow. But it is an attempt to try to get especially developing nations more engaged and more resistant. Then we start driving things down to more of a national level and national programs. And I'm in the US, so I'm most familiar with the programs here in the United States. The National Institute of Standards and Technology has 5 components to their resiliency program. It starts with guides and analysis tools. And their guides, they have a planning guide for communities, volumes 1 and 2, that help communities identify what their stressors are, how they can take approaches and what approaches might be available to them to develop a good resilience planning. And this includes emergency response, recovery. It's more than just the construction, design and construction. They have a good modeling program, INCORE, or they're working in cooperation with this modeling program, which is INCORE, which helps them model the types of disasters and events that can occur. One of the biggest issues that is out there for communities or anybody who's interested in trying to deal with the disasters and potential disasters are, as Julie, Scott, and Jeremy alluded to, everything we do to date is based on historical records of disasters, but we know there's sea level rise. And we don't have sufficient credible programs accepted to allow communities to make judgment calls about what they need to do and where to put their financial investments and where to restrict construction or require different construction in order to resist storm surge, additional flooding, and other things that are related to sea level rise. The climate change that's related to sea level rise. There will be more cloud cover. There will be more storms. There will be more intense storms. These are all interrelated, and we have great programs to model based on what we know, but nobody has yet come up with definitive models for what we can anticipate in the future. And if you're building a building that's going to have a 100-year design service life on the coast, you should have a pretty good idea of where those water levels are going to be in the future. So, and then they also have another tool, the economic decision software, that then gets people, once they have modeled what the disaster impacts might be, that allows them to assess what types of investments might need to be made in order to come up with an effective program. NIST also continues to support efforts and work with the Federal Emergency Management Agency on investigation of structural failures and responses to those failures. And they support efforts. This happens to be Rapid Cities, Iowa, 2008. They worked with that community. And their observation for working with any community is these often require huge upfront costs. And funding tends to be difficult at any time, but it's especially difficult in the aftermath of a disaster. So going into a community right after a disaster and saying, well, you should have done this, and this is what you need to put in place. Well, they're more concerned about just getting it back up and running the way it was rather than building it back better. So getting funding is a huge challenge, but they are doing this with the help of some federal grants to put in some flood control. The project started in 2016 and is expected to be completed, I believe, in 2023. So there's also earthquake risk reduction as part of their programs on resiliency. The collapse assessment and performance-based engineering, earthquake engineering, are two things they work very closely with the National Earthquake Hazard Reduction Program, NEHRP. And you heard, I believe, Scott talk a little bit about, and Julie talk about the Building Seismic Safety Council and performance-based design. So that's helping us to even improve more so what happens with earthquakes. Gonna digress here a little bit to say that in the United States, at least, and I think it's global, we do a pretty good job of dealing with earthquakes because there's no warning system for earthquakes. So the way we address disasters related to earthquakes is we do collapse avoidance, and that saves lives. For almost every other disaster that happens, hurricane, wildland fire, tornado, other wind events, floods, what do we tell people to do? We tell them to leave. That's our life safety. We evacuate. They may go back to scoured slabs. They may go back to burnt out structures, but we didn't lose any lives. So the intent of the building code is satisfied by having this evacuation. It's not sustainable and it's not resilient, but that is what is currently accepted in our society. They also have a program on resilient materials, and this is about quantifying how materials will perform. It's getting into fairly detailed and complex analyses and evaluation procedures, but they do have some programs related to reinforced concrete columns and components in reinforced concrete frame systems. They're trying to figure out trying to get a better handle on determining the uncertainty at the component level and the impacts of loadings on these structures as they get to extreme loading conditions. They have already completed a project on steel beams. This project is still underway, and then they're hoping to integrate these results with some of the information they have on steel beam column connections. Then finally, the fifth component is the windstorm impact reduction, the calm before the storm. Again, they're working with other agencies. They are supporting the reauthorization of the National Windstorm Impact Reduction Program and providing input to our load standards. So with the windstorm reduction impacts, structural performance for multi-hazards, what happens when you have a fire after a windstorm? What happens when there's flooding combined with a windstorm such as a hurricane? These are all interrelated and things that need to be considered and addressed. We lost a lot of facilities after Hurricane Katrina to fires after the disaster. There were most of the damage, even back into the 1908 San Francisco earthquake, was fires after the earthquake. It wasn't the earthquake itself that destroyed the city. It was a combination of the earthquake and with more damage actually happening from the fire and gas explosions that occurred subsequently to the earthquake. So they're also looking at performance-based seismic engineering projects and trying to categorize coastal inundation and the structural design to resist those efforts. One of the outcomes from this is information, and again, this is a cooperative effort with multiple agencies through NIST, working with ASCE 7. There will be new tornado load provisions in the next edition of ASCE 722. We have handled we've handled tornadoes for decades. We've handled them in a little bit of a strange way because we evaluated the tornadoes on the enhanced Vegito scale. So it was determination by the amount of damage. These are both F4 tornadoes. One went through a town and you can see what kind of damage it did. So you knew that that was clearly an F4 tornado. The other tornado is going through a farmer's field. There's no way of telling. So we don't have good records on where the intense tornadoes have actually occurred because we don't have any physical records of the damage that could have been or that would have happened if it actually hit structures. So they're changing this because the Weather Service is now getting good about measuring the wind speeds of tornadoes regardless of where or what they're striking. So putting these loads into ASCE 7 is really going to help improve design for tornado resistance. The Federal Emergency Management Association has multiple programs to mitigate against hazards and improve functional resiliency of structures. The key thing, one of the key things is they have an incentive program for communities or any authorities having jurisdiction that they will increase the funding available after disasters or for mitigation by 5%, under certain conditions, and that is that they have a good building community emergency. I got to go to my next slide. Building code effectiveness grading scale or schedule. This is the source of this is ISO. This is not the International Standards Organization. This is an insurance organization that evaluates states based on the level of code that they have in place. And it's not just the provisions of the code, but also the enforcement of the code. So this comes from the insurance companies. And if you have a program in place that's going to elevate you to a higher level on the schedule, then that will help you qualify for help that community or authority to qualify for increased funding to incentivize mitigation. One place where FEMA has helped a community along a lot, and the community was fairly innovative with how to address flooding issues, is they actually assisted through grants the community to buy out residents and businesses that were located in the floodplain. We have a lot of structures, especially in older cities, that are immediately in the floodplain. And the reason they were in the floodplain is when they were first built, commerce, everything was dependent on those waterways. So that's how they got located there. And for the benefit of being able to conduct business and have access to those waterways, it was worth the risk of having your structures there. Well, those waterways are no longer in many of these jurisdictions. Those waterways are no longer the primary source of transportation or moving goods. So they don't need to be there anymore. So in combination with the grant, the Mecklenburg County, Charlotte, North Carolina, also incentivized the developers by relaxing the density requirements, allowing more dense development in certain areas where they wanted these buildings or these people to be able to move to when they were buying out and demolishing their homes and turning the wetlands into parkland. So it turned out to be a really good model of a way to incentivize the developers, provide affordable housing as they were buying out houses and businesses in the floodplain. The National Institute of Sciences has multiple programs related to resiliency or have resiliency components in their councils and projects. But the four that come to the top are, number one, the Building Seismic Safety Council. They develop through NEHRP, research is done about earthquake engineering. Then the Building Seismic Safety Council has a group called the Provisions Update Committee, and they take that research information and they figure out what is worthwhile to try to put into the code. And once it goes through that process, those recommendations then in turn get fed into a consensus standards development process through the American Society of Civil Engineers Structural Engineering Institute. But they also have the Multi-Hazard Mitigation Council. This has been very active in trying to figure out what the disasters are, what happens when you have multiple hazards, and also trying to come up with ways to invest and fund mitigation techniques. From that council, there was an offshoot, which then became the Council of Finance, Insurance, and Real Estate, because those are the people who are ultimately going to determine the investment levels. And it gets, again, it gets really complicated. When you talk prior to the 1950s, most insurance, excuse me, most insurance was risk-based. That is no longer the case. Almost all insurance that's out there now is actuarial. So that means there's a pot of money and the insurance companies are just betting that they won't have a lot of losses at any one time. Then as we approach the global economy, what happens is the insurance companies get reinsured. So now you have all these insurance companies from around the globe putting money into a pot where they are now reinsured, because the likelihood that if there is one major disaster in one country, it's not going to be a global disaster. So it has changed the insurance industry's interest in making sure that projects are resilient, and it also helped lead to relaxation of the codes. The first codes that we were having in the United States were pretty much driven by the insurance industries. And over the years, they have gradually become more and more relaxed because the financial impacts of losses is not nearly as great for the insurance companies. So there have been these dramatic societal and cultural changes that accompanied that. And then finally, there's the whole building performance guidelines. With the National or Multi-Hazard Mitigation Council, the first study that I was serving on the council, and the first study that we came up with was released back in 2005. And it showed that there was a potential savings of $4 to $1 for every dollar you invest in mitigation, you save $4 when there's a disaster. Unless you have the disaster, you don't get that reward. So it's still a difficult challenge to convince people to make those investments and find the incentives to get people to make those investments. But the study was redone, just recently released. I think it was released in 2017, and it used new data, and it also looked at what happens when you go beyond code. They looked at 20% load increases for seismic and wind events. So when you look at the beyond code requirements, this is making buildings and structures more resilient, but there's still a significant payback. And they also broke it out between federally funded grant programs and private sector. So there's a lot of good resources here, a lot of great programs. Resiliency and enhanced resiliency is not new. Every structure has some degree of resilience to it. Will it withstand a disaster? We have no way of knowing. So But FM Global is a good example of one insurance company that works with owners to enhance the resiliency of structures. They work with them about foreseeable loss. They have great resources. Back in 1994, or prior to 1994, Anheuser-Busch in California invested $1.2 million in seismic retrofits. Northridge earthquake occurred. Anheuser-Busch considers that they probably saved $1.1 billion in combined property and business losses because they were able to stay operational. This is the type of thing that has been going on and will continue to go on. Even in the building code, we have some enhanced resilience requirements. How do we determine that? Well, we have buildings in the building code in the United States. We place buildings into one of four categories: low risk to low potential hazard to human life, Buildings not in categories 1, 2, and 3, which I will get to, that's most buildings. Substantial risk to human life, which is large assembly or large educational or institutional facilities. And then category 4 is essential facilities, fire, police stations, emergency shelters, and hospitals. So we have these risk categories, and what happens is if you have a high volume facility, a large high volume facility like that Anheuser-Busch, that's voluntary. The owner wants a resilient building. They're willing to invest. Risk categories 3 and 4, the code says enhanced resiliency to some degree is actually mandated. But then all the other structures where the owner has little potential for involvement to influence the operations, they have no influence on how their building is being built. So there's other organizations, the Institute for Business and Home Safety works very closely. Julie highlighted some of this. There's also now the Alliance for National and Community Resilience to develop and benchmark criteria for communities to consider. There's the USGBC RELY that Julie covered, so I'm not going to get into the details there as we're running out of time. There's the more global provisions of ISO, and almost every one of these activities and efforts could probably fill a session here at ACI, but ASTM is also now starting to write a fair amount of resiliency standards and criteria. And we have some, especially on existing structures, to help improve the resiliency of communities available. One thing I'd like to quickly point out here is ACI is you. If there's needs for standards and needs for guides and information on topics, get together, get involved in a committee, form a committee if needed, and work on bringing that information together. Another thing to bring this full circle goes back to the California initiatives, which is where U.S. Resiliency Council started their focus. They are now expanding their efforts to more than earthquakes, but they are still looking at, coming up with a rating system based on recovery and the potential for disaster. So these efforts continue, and thank you, and hopefully you can get out there and do lots of things to help address chronic stresses and acute shocks for our buildings, infrastructures, and communities. Thank you.